All right. So another classification of reactions are your decomposition reactions. All right, if you recall maybe what a decomposer does from biology class, it's like bacteria that eat rotting things. All right, decomposers do what? You said something along the lines of like break things down or disintegrate things. That's exactly what I want you to be thinking of as you think about what decomposition reactions are. So decomposition reactions are the exact opposite of synthesis. All right, so decomposition reactions are going to take that complex compound and split it into its smaller pieces. So you could just take a synthesis reaction and reverse it, and there you've got decomposition. So again, write this generic formula down so that you have an easier time spotting these when you're, looking at a list of reactions and things. So, if you remember, decomposition is a, pair of chemicals that are bonded, and then they get split apart. So looking this one, you can kind of start by looking at your reactants. There should only be one reactant, and then that reactant should get split up in its products, so you'll have two products. All right, so I've got two reactants, two products here. That's not it. This is what kind of reaction is this one? Quick review here. Produces a whole bunch of energy. But that's also, combustion reaction is also not a decomposition reaction. This is looking promising. We have one reactant, Cu copper oxide, and then it's getting split into copper and oxygen. And then here, this is the exact opposite of what we are looking for. This is two reactants forming one product, also known as a what kind of reaction? Synthesis. All right, so that means C is your correct answer. All right, looking at the second set here, which one is the decomposition reaction? So take your time, look them over, pause the video if you need more time. The right answer is A. All right, let's practice some balancing. We've got sodium chloride, or our good old table salt, being split into sodium atoms and chlorine molecules. All right, so we've got one each in our reactants, one sodium, and then chlorine forms diatomic molecules, so there's two chlorines coming out in our products. So we are not balanced. These do not match up. To fix our chlorines, I'm going to put a coefficient 2 out front. I am not allowed to change the formulas. All I can do is say that I need to put in 2 salts, 2 sodium chlorides. That will fix my chlorine issue, but that's also going to double my sodiums in the reactants. But now chlorines are balanced. Next, let's balance our sodiums. If I put a 2 in front of sodium, that'll double my product sodiums, and now those are balanced. Right? If I had asked you to tell me what you got before starting this, I would have wanted to see 2, 2, 1, because that's the order of how you would fill in the blanks. So, what type of reaction is this? We're in the decomposition lesson, and I'm not trying to trick you. It is a decomposition reaction. Now I want you to balance it. So let me know what should go in those blanks. So you can, do 3, 1, 2, 3, 1, 2, or whatever ends up balancing that. If you need more time, pause it here. But I would set it up like this. I'm going to have lithium and oxygen. Lithium, oxygen. 1, 2, 1, 2. Oh, and look, they're balanced. I don't even have to do anything. 1, 1, 1.